Okay, another important terminology that you have to understand, noise figure. So I'm touching upon some key terminologies so you can note down. I think once you read after the class, you can always connect these different specifications, terminologies, then you'll understand better. Okay, so noise figure. So first let us define what is a noise factor. So noise factor, it's a ratio, again see, again ratio, we're talking about ratio, okay? SNR in by SNR out. And we have seen in the previous slide what is SNR. SNR is signal to noise ratio. Now we are taking a ratio of two ratios, okay? SNR itself is a ratio, but it's one number once you take a logarithm or a dB or a number, okay? So then we take a ratio of SNR into SNR out. So what does that mean? Let's say I have an RF device, it will have some SNR, right? So basically, if you remember that, super heterodyne or ZIF or whatever those architectures, you had different blocks, right? You had different blocks there, amplifier, filter, mixer, all that. And obviously, if you have a way to measure, you can always measure SNR at different points. I can measure SNR here. I can measure SNR here. I can measure SNR. Basically, SNR is signal to noise ratio. At every point, you can measure SNR. Okay, if you have a way to measure it. Now let's say if I have one of these blocks, let's say this is a block RF device. There is obviously some SNR at the input, then there is some SNR I can measure at the output. So what does noise factor say? Noise factor tells you the degradation of SNR, okay, degradation of SNR as the signal moves from SNR, as the signal moves from input through the device to output. Okay, so what it means, there is some SNR here, X, it degrades. That means it becomes worse and it becomes Y. So Y is worse than X. Okay, so that's what noise factor will tell you. So every device add noise. So how does this degradation happens? Because every device, so here SNR means signal to noise ratio. Not only this noise which is entering the device, but this device also adds noise. Okay. So since every device adds noise, we are using noise factor to calculate, what is the impact of this added noise. So this device has added noise. So we want to see what is the impact of this noise. Okay. That's why we have this factor called as noise factor. And amplifiers, they are supposed to give gain. But you'll be surprised to know that they also add noise. They not only give gain, they also add noise. Okay, so that means they also make the signal worse apart from giving gain. Okay, so every device does this. So how does SNR degrades? So basically, when we say degradation, what does it mean? SNR out is going to be less than SNR in. Okay, correct? So we said that SNR in, you have some SNR, and this adds noise, and then at the output, you get another SNR, which is obviously degraded. That means this number is more than 1. Right? You have an SNR here. SNR out is actually lower than SNR 1. So we are saying a number which is more than 1. So see this example. I've taken amplifier as an example. So what is S in? Signal in, noise in, goes inside this amplifier, and amplifier adds its own noise called as N amp, and this amplifier has a gain of G. Now without this noise, what would have happened? If you feed S in and N in into this amplifier, output will be signal multiplied by gain, noise multiplied by gain. Okay, because you have the amplifier is supposed to give gain, whatever comes from the input. Now because of this noise added by the device, apart from this term, you also see noise getting added. Now if I take SNR here, it will be something like this, right? But if you consider here, it is plus N amp. Okay, you have more noise in the denominator. So what happens? Your denominator is more. So that means this ratio is going to be smaller compared to S in by N in. Okay, so that's how the SNR degrades. Now I told you everything we have to take it in dB. So what is noise figure? Basically you take the noise factor, take 10 log 10 of that, you'll get noise figure. Okay, once you have a log, you don't have to divide, you just have to subtract. So that's the advantage of taking a dB scale.
Please click on like and subscribe to our channel and click on the bell icon for regular updates.